Okay, I built a, you know, set of probes for this LCR meter here, which this is a, you know, SR715 by Stanford Research Labs. And as you can tell, this thing's like got a lot of smoke damage from a fire and stuff. It's, bought it in the late 90s, and, really it's been sitting around in sheds all this time. It still works, actually. You can still get these off eBay for 300 or 400 bucks. But in a lot better shape than mine is. But anyway, one thing that when I bought this thing, it just came with this little adapter, okay, and that's great for testing leaded components like this inductor here, and hey, it works great, but if you want to test capacitors or something like that, or bigger inductors or anything offline, you need some kind of probes, and the probe sets were really expensive. In fact, you can find them off eBay for like $200 a set or so, but that's kind of ridiculous when you can buy one of these whole units for 300. But at any rate, I just really quick and dirty threw together, some probes. I bought these Kelvin clips off of Amazon for like less than 20 bucks, and really good quality little clips. I actually did build a set prior to this that was, where you bought the clips themselves, but they're really, really cheesy, and I had to put my own springs in it and stuff because they were so weak. But anyway, I decided just to, take a circuit board, and something I don't like about this camera, it's hard to control. But anyway, I just, basically took a little circuit board, just a piece of FR4, 62 mil circuit board, and I just soldered some banana clips on it, because these Kelvin clips, are gold-plated banana clips, but I use them for a different project. A little milliohm meter I built. I saw on Cassian TV or somewhere with a 317 regulator. It was a high enough voltage supply that's actually was surprisingly accurate. But anyway, but yeah, I just took some banana clip sockets, out of one of those, kits like this that you can get off eBay, off Amazon, so they're kind of cheesy little clips, but I just soldered them directly to both sides of a piece of double-sided circuit board I cut up with a, multi-tool, and just for something quick and dirty, because I kind of doubted this thing would work, but in fact it does pretty much work. But yeah, you just plug the banana clips into either side of it, and then you just plug it into your little meter, and this technique should work with anything that needs Kelvin clips. So if you'll notice, this doesn't have any kind of guard or anything, but again, they made a fixture, they didn't have any kind of a noise guard or anything on it. I have a feeling they have a low pass filter on this thing, because this one only goes up to 10 kilohertz, unfortunately. The one you'll see on eBay is the 720, that goes up to 100, but this is really super accurate. You can actually measure the inductance of a few inches of wire. I mean, it goes down to the nanohenry range easily. So and it'll measure something like I think 1,000 henries or something like that, and 99,000 henries rather, I think it is, and it measures up to just under 100 millifarad capacitor wise. So it's a lot better than most of the meters you get out there. And in fact, if you look into this, the manual's got complete schematics in it and details on how to, the calibration procedures they used. And, I mean, this was, back when I bought this, you could either buy a $50 LCR cheesy meter that didn't do shit, or you could buy something in the $1,200+ range. So, I mean, this was like the cheapest actual LCR meter available back then, pretty much. But it's still really good quality and from a good source. But at any rate, you just have to basically put your clips on it. So let's see. Yeah, I'm trying this with a webcam this time, so try to get away from cell phones. But you can see, you know, there's a slight difference. I haven't calibrated the thing because you can do a calibrate. You know, this has its own version of a salt test, like on a Nano VNA, where you do, you know, at least a short and an open. But still, even uncalibrated, you know, I mean, it's not bad. So, you know, yeah, that's 308 versus 305. So I mean, you know, that's not bad for 305 microhenries. You know, that's not a bad error for just plugging this in uncalibrated. So, but anyway, for, you know, what I really made this thing for, you know, so you can calibrate, you know, like let's look at this 35,000 microfarad conductor. You can see what the our capacitor. You can see what the markings are on it here. That's what I like about this camera, is that you can focus it. It's awesome. Can't do that with my smartphone for close up. But I'll put this on these screws. Sometimes cause problems, you know, if they're not in there well. Let me see if I can get a good reading just right off the bat. Nope. Let's see. Damn it. Sometimes these things don't seat in there well. It's not, yeah, it's these screws. Hold on. Let me, try it on this one. Oh, yeah, you know, that's the thing, this thing freaks out if you don't have it set on the right range. Let's see. It'll take some finagling. Hold on. I guess it'd help if I put it on capacitance. Okay. So 84,000 microfarads. You know, I don't know if that resistance is right, because like I said again, it's, these screws can kind of wreak havoc on it. Yeah, it's about 100 and, you know, 38, 140 you know, milliohms, which is pretty high, you know, for this capacitor. So let's see, yeah, it's about 150 milliohms. So yeah, this probably isn't in the greatest shape. It's a really old capacitor from, you know, like the late 70s or early 80s. Well, it's only 15 volts though, so you might expect a slightly higher resistance. So, but at any rate, the point is that, yeah, it can measure that. And let's see if it works with this other one now that I've got the range sorted out. There we go. Hold this camera is a little awkward. Okay. Okay. Yeah, that's a 35,000 microfarad cap, and it's measuring 34,000 with a 6 milliohm impedance. And again, this is probably, you know, for the early 80s. So I mean, these capacitors are really, really old. But you know, like I said, it does a good job. And like I said, this is what else I like about it. Damn it. Well, here, let me attach it back to the big one here so you can see how fast this meter reacts. I mean, you know, attach the test clips and you can see, damn it, see, it's just almost instant that it gives you a reading. So, resistance is a little different because I tested it a little differently, but it's almost instant. I mean, if I try using that thing to even measure a 16,000 microfarad capacitor, I mean, literally, you'll sit there for, several minutes waiting for it to come to a conclusion. So, and most meters are like that. They're really slow the bigger the capacitor. This thing is just wicked fast. And it's the same on inductors too. I mean, it'll measure inductors, large inductors, really fast. So it's a pretty cool little meter, and it's like I said, it's been sitting around, and ever since the fire in 2003, it's been sitting around in lawn sheds and and non-climate controlled buildings. I'm just shocked that it still works, especially with this much smoke damage, let alone works this well. Because believe me, I've tested it with a lot of other components, and a lot of other components, even microhenry range inductors, even lengths of wire, like I said. But at any rate, that's a quick and dirty way to make little clips. So hey, it works. I was surprised it was that straightforward with this amount of accuracy without, like I said, even calibrating it. And of course, there are other ways, of measuring LCR. You got like the nano VNA and those little these little component testers like this, which, believe it or not, this is the next most accurate tester I have, and it'll go up to 100 millifarad too, but of course with significant error compared to this thing. But this thing bought for $15 on Amazon several years ago. That's actually the best, the next best one I actually have. I bought this one fairly recently for about $20, but man, this is nowhere near as accurate as this old one. It's got a nice color screen to it. It's still good for transistor testing, but that old one is more accurate. I mean, it's not accurate, but it's more accurate. That's the closest thing to an accurate meter I have outside of this. But one meter you do not want to buy is this motherfucker. I got this for like $34 off Amazon, and this thing is a piece of shit. I mean, if you can see it, you can see that, like I said, it only goes to 2,000 microfarads. Every other capacitor meter I have at least goes to 20 millifarads. This only does 2 millifarads. That's ridiculous. And it will not, it says it's supposed to go down to the microhenry, 1 microhenry or lower, but it doesn't. I mean, you can't get anywhere near that. I mean, you're lucky to be able to measure 1 millihenry with any accuracy at all on this thing. And this is a piece of shit. If I'd have known how big it was a piece of shit, I would have sent it back. And look at the maximum range, only 20 mega ohms. Wow, all my DMMs do that. Nothing special there. This son of a bitch, this will measure giga ohms. So, in fact, I didn't really intend on going off on a tangent here, but let me, where the fuck is Chrome? Damn it. Okay. Oh, come on. Let's see. Make sure this is in the shot here. Yeah, here's the data sheet on it, on this, particular meter. And again, you probably could get something newer, maybe with better specs, but I haven't seen anything, certainly for the price you can buy one of these on eBay that has similar specifications. Let's see. These are the different frequencies it recommends. And again, this one doesn't do 100 kilohertz, but again, the 720 does, and that's the one you mostly see on the eBay. So that's the higher dollar model. It was like a few $100 more, so I didn't buy it back then. I wasn't sure what my needs were. But at any rate, it shows you what frequencies you should use on various ranges and stuff, which is nice. And they go into the theory. Shit, I don't know. This may not be. I don't want to clip the screen for you. I'm sure it's showing up in the shot here. but yeah, it's got, pretty decent specifications, and like I said, given how, the condition it's in and how well it works, I mean, that's saying something about how well this thing was built. I'll tell you. This gives you the ranges of some of this stuff, and the accuracy. That it can be 5% there and 1% there. Again, I can't attest to that. There is a complete calibration section on this, but you got to pop open the cover and have some really fancy equipment to calibrate it. It's half this manual is devoted to calibration, actually, and the procedures they use, and communicating with it on the PC and writing code for it and everything. But you can see the resistance, will go up to 2,000 mega ohms, so that's like 2 giga ohms. So that's not a typo. So I mean, this thing's really capable. But of course, it's not DC resistance. It's but you got like 4 frequency ranges, 100, 120, and 1,000 and 10,000 on it. But you can see it does 99,000 henries, 99,000 microfarads in these two ranges. So I mean, it's got a lot of interesting features to it. So if you look down in here, they really don't give you a lot in terms of information on the operation of the unit per se, but it's pretty intuitive to figure out. But yeah, if you go down towards the bottom, like I said, they got complete circuit board layouts, and they really don't have a lot of like FPGAs or anything, because this is something that was a 1990s instrument. So the mid 90s or so they came out with this, I guess. Early to mid 90s, but I bought this in the late 90s, new. But yeah, they've got like complete schematics here and everything, so it's hypothetically repairable. If you needed to, a complete parts list. I mean, it just goes on forever. To get into the calibration of it, how to take it apart, how to troubleshoot it, etc. So I mean, it's a really pretty decent little manual when it comes to stuff like that. And they go into the performance and how they evaluate it. I mean, it's a real professional machine, not something you're going to buy off Amazon or eBay. I mean, this is actually completely a serious instrument. It's not. It's not. Some cheesy little piece of junk like that. Meter I showed you. But at any rate, another way of measuring capacitance and so forth. Again, is a nano VNA, but you can't measure very large inductors or capacitors with that. But then the analog, the analog discovery, certainly, can measure quite a bit, although it's only rated up to 500 microfarads and so forth. But it's but you can measure a lot of parameters on it using its um, impedance meter functionality. I was looking at some of these other meters recently on Amazon like this before I really got into seeing that verifying that this thing worked reliably enough. But if you bring up the specifications on these, they're not nearly as accurate. But there was an interesting little capacitor meter I was kind of looking at on here that was new, and that's this one for $39. This will actually measure up to 500 farads. So, but it's just a capacitor meter. It's not an LCR meter, but it's actually pretty impressive, especially for the price. It's got relatively decent reviews on it and everything. Do ESR and some stuff like that, but apparently not to too great an accuracy, as you can tell there. But still, maybe accurate enough though. But anyway, like I said, this one you'll see a lot on the internet, but it's not really even a capacitance meter. So, it's got a little chart and everything, but you can get that off the internet for any kind of meter. So, but anyway, like I said, you know, those are your choices pretty much for LCR meters. But yeah, a lot of people really love this DE5000, but again, if you actually look at the specs on it, it's not as impressive as this. I'll put it to you that way. So, but at any rate, it's certainly cheaper. I mean, and that would be the meter I'd probably buy maybe if I didn't have this one. So, um, and I looked at some of these, the few $100 range, and they're anything but impressive. If you look at the specs on them, most of the meters on Amazon won't even tell you what the ranges are, for crying out loud. How dubious is that? But like I said, you can kind of compare it. This only goes up to 9 millihenries, or I mean 9,000 henries versus 99,000 for this device. And so you can see what the range differences are. And I was, I guess it does 99 mega ohms, which is pretty impressive. So most DMMs won't do that. So you can't argue with it. And like I said, a lot of people really like this meter. Or I mean, no, not. I mean, not this meter, but the other one, the DE9000. I mean, supposedly it'll go down to, I mean, it's not bad, going down to, it looks like, 100 microohms or whatever. Like I said, you compare it to this range, like I said, this will go, down to, about 10 microohms. So, oh no, I'm sorry. About 100 microohms. So it's got about the same kind of range as this one when it comes to resistance. So again, I actually got a much more accurate milliohmometer off of. Oh, you've got to be shitting me. Hold on. But yeah, I've got a more accurate, little milliometer off of, eBay. It's mostly in Chinese, though. That's what sucks. There's no way to put it in English. But this thing, does really, really decently. I was really shocked. It was only like $60. Anyway, that pretty much, covers the subject, in more depth than I intended. So, anyway, cheers.